Google, quantum computing, parallel universes. These words alone ignite curiosity, but the truth behind them is far more unsettling than you can imagine.
We all know that digital computers changed virtually every aspect of our life. Well, the arrival of quantum computers could be even.
Ethical hacker from Montgomery claims to have uncovered classified files, exposing a Google experiment so dangerous that it was abruptly shut down. What they found: anomalies, strange signals, something beyond explanation. The experiment may have inadvertently opened a doorway to parallel realities, retrieving answers from different universes simultaneously. Even the scientists behind it don't fully understand how it works. Was this a groundbreaking breakthrough or a catastrophic mistake? Buckle up, because the truth about quantum computing and its eerie implications might forever change the way you perceive reality. This is chilling. So, without wasting any time, let's dive straight in. Are they sharing data between universes? To fully grasp the magnitude of Ryan's discovery, we need to understand the basics of quantum computing and how it differs from traditional computers. Quantum computing sounds like something out of a sci-fi movie, a mysterious technology with the potential to rewrite the very rules of computation. But what is it really, and how does it differ from the digital computers we use every day? Breaking down the basics. Let's begin with traditional computers. Whether it's your smartphone, laptop, or gaming console, all of these devices rely on the same fundamental building block, bits. A bit, in case you didn't know, is the smallest unit of information and exists in one of two states: 0 or 1. Every app you use, every video you stream, and every message you send is nothing more than an enormous series of these ones and zeros, processed at lightning speed. This binary system is efficient, but fundamentally limited by its rigidity. Now, enter quantum computing, a total game changer. Qubits, the strange power behind quantum computing. Instead of bits, quantum computers use qubits, short for quantum bits. Qubits are nothing like their classical counterparts. Unlike regular bits, which can only be 0 or 1, qubits can exist in both states simultaneously, a phenomenon known as superposition. Think of a traditional computer trying to solve a maze. It would test each possible path one by one until it found the exit. A quantum computer, however, explores all paths at the same time, drastically accelerating the solution process. But that's not all. Quantum computers have another bizarre ability: entanglement. Einstein's spooky action at a distance. Entanglement is where things get truly strange. When two qubits become entangled, their states are interconnected, no matter how far apart they are. Change the state of one qubit, and the other instantly changes, as if they are communicating faster than the speed of light. Even Einstein was baffled by this, famously calling it spooky action at a distance. To this day, entanglement continues to perplex scientists. Together, superposition and entanglement allow quantum computers to process information in ways that classical computers never could. Tasks that would take thousands of years, such as cracking advanced encryption or simulating complex chemical reactions, could be completed in mere minutes or seconds. Why aren't we using quantum computers yet? If quantum computers are so powerful, why aren't they mainstream? The answer lies in their extreme fragility. Unlike your smartphone, which functions perfectly at room temperature, quantum computers require ultra-cold conditions to operate. Qubits are incredibly sensitive, and even the slightest environmental disturbance, like a stray particle or a minor temperature fluctuation, can cause critical errors. This makes building and maintaining quantum computers a monumental challenge. But that hasn't stopped tech giants from trying. Google's breakthrough and its dark implications. Companies like Google, IBM, and Microsoft are in a heated race to develop the world's most powerful quantum machines. One of the biggest milestones in this race came when Google unveiled Sycamore, a quantum computer that reportedly achieved quantum supremacy, solving a problem in mere seconds that would take even the fastest classical supercomputers thousands of years to complete. But quantum computing isn't just about speed or power. It's about the unknown, As we push the limits of what these machines can do, we are also stepping into uncharted territory, where the very laws of physics and reality are being tested. And this is where things take a darker turn. Are we crossing a dangerous line? What happens when we push too far? Are there boundaries in science that should never be crossed? As you'll see in the next chapters, the answers to these questions may be far more unsettling than we ever imagined. Why big tech is betting everything on quantum computing. Quantum computing isn't just another buzzword in the tech industry. It's the holy grail of innovation. The stakes are unimaginably high, and the biggest players in the game know it. Google, IBM, Microsoft, and even lesser-known contenders are investing billions into this technology, racing to unlock its full potential. But why the urgency? What makes quantum computing so valuable that it has ignited what some are calling the new space race of the 21st century? To answer that, we need to understand one crucial fact. Quantum computers have the potential to solve problems we don't even know how to ask yet. Quantum computing, a technological revolution or a looming threat. Computers today are already incredibly powerful, but quantum computing promises to achieve the impossible and do it at unprecedented speeds. Take artificial intelligence AI, for example. Currently, training AI models requires immense computational power, time, and energy. A quantum computer could revolutionize this process, analyzing massive datasets and optimizing algorithms in record time. Imagine AI that is smarter and faster, capable of diagnosing diseases, predicting natural disasters, or managing intricate supply chains with near-perfect accuracy. The cryptography conundrum, a digital arms race. Modern encryption methods, like those protecting your online banking, rely on complex mathematical problems that are nearly impossible for classical computers to solve. The key word here is nearly. A sufficiently powerful quantum computer could break these encryption codes as easily as solving a simple puzzle, making current cybersecurity obsolete. It's no surprise that governments and tech giants are obsessed with quantum cryptography, racing to stay ahead in this digital arms race. But quantum computing isn't just about number crunching. It could transform entire industries. Quantum computing's impact across industries, pharmaceuticals and medicine. Quantum computers could simulate molecular interactions with extraordinary precision, leading to breakthroughs in drug discovery. Imagine curing diseases faster, developing vaccines in weeks instead of years, personalizing treatments for individual patients based on their unique genetic makeup. The energy revolution. Quantum computing could optimize power grids, enhance renewable energy storage, and even simulate nuclear fusion reactions, a potential game-changer for clean energy, space exploration, climate modeling, and finance. From designing next-generation spacecraft to predicting climate patterns and revolutionizing financial markets, quantum computing has the power to unlock insights and solutions that classical computers simply can't match. The dark side, ethical concerns, and global power struggles. With great power comes great controversy. The rapid advancements in quantum technology have sparked serious ethical and philosophical debates. What happens when quantum computers can break every digital security system? How do we regulate a technology that could shift global power dynamics? Big tech isn't chasing quantum supremacy just for innovation. It's about control. Whoever masters quantum computing first will hold the keys to a new era of technology. Governments know this. That's why the US, China, and the European Union are pouring billions into quantum research, treating it as the next battleground of global supremacy. Some even calling it a new Cold War. What are they hiding? While companies like Google and IBM celebrate the breakthroughs of quantum computing, they're far less transparent about the risks. Pushing the boundaries of physics has consequences, ones we may not yet understand. Rumors persist of classified experiments gone too far, whispers of discoveries so profound and so dangerous that they are being kept hidden from the public. Could it be that scientists have already uncovered something they can't control? As we'll explore in the next section, quantum computing isn't just about progress, it's about power. And when power like this is unleashed, the consequences can be terrifying. Quantum computing doesn't just promise revolutionary advancements. It poses an unprecedented risk to global security. To understand why, we need to examine one of the foundations of our digital world: encryption. Encryption safeguards everything from your bank accounts to government intelligence. Every time you log in, send a private message, or shop online, encryption ensures your data remains hidden behind complex mathematical locks. These locks are so difficult that even the world's fastest supercomputers would take millions of years to break them. But quantum computers don't play by the same rules. The encryption breaker: how quantum computers destroy digital security. At the core of modern encryption is public key cryptography, a system that uses two keys: a public key to encrypt data, a private key to decrypt it. The security of this method depends on complex mathematical problems, like factoring extremely large numbers, a process so time-consuming that classical computers struggle to solve it. But quantum computers operate differently. They can process multiple possibilities simultaneously, allowing them to solve these problems exponentially faster. Enter Shor's algorithm, the encryption killer. Shor's algorithm is a quantum algorithm capable of factoring large numbers at unprecedented speeds. For context, a classical computer would take thousands, even millions of years to crack a 2048-bit encryption key. A sufficiently powerful quantum computer could do it in hours or even minutes. This isn't just an advancement. It's a security catastrophe. The fallout: a world without privacy. Imagine a future where your bank transactions, medical records, and personal emails are no longer private. Entire financial systems are destabilized overnight. Military communications and government secrets are exposed. Governments and corporations are already scrambling to develop post-quantum encryption, new security methods designed to resist quantum computing's immense power. The most terrifying possibility? They're already collecting your data. Here's the unsettling part. Quantum computers don't need to wait until they're powerful enough to break encryption in real time. Hackers and state-sponsored cybercriminals could already be harvesting encrypted data today, storing it for the moment when quantum computing becomes advanced enough to decrypt everything in an instant. What happens when that moment arrives? As we delve deeper, we'll uncover the terrifying reality of who controls quantum computing and what it means for the future of security, privacy, and power. The looming threat: harvest now, decrypt later. Quantum technology isn't just about solving complex problems. It could rewrite the rules of cybersecurity. One of the biggest concerns in this field is the harvest now, decrypt later strategy. Right now, cybercriminals and state-sponsored hackers may already be collecting encrypted data, storing it for the day quantum computers become powerful enough to break encryption instantly. This looming threat has sent shockwaves through cybersecurity circles, and the dangers don't stop there. Quantum computing versus blockchain, a new kind of cyber threat. Blockchain technology, the backbone of cryptocurrencies like Bitcoin, relies on cryptographic principles to secure transactions and maintain trust. But what happens when quantum computers can crack these codes effortlessly? A quantum-powered attack could dismantle that trust, causing massive economic ripples and undermining the very foundation of digital finance. The ethical hackers fighting back. While the threat of quantum hacking grows, ethical hackers like Ryan Montgomery are working on the front lines. These cybersecurity experts push the limits of technology not to exploit it, but to expose vulnerabilities before they can be weaponized. Montgomery and his peers are probing quantum systems, warning the world of the dangers lurking just beyond the horizon. But encryption is only the beginning of the story. Beyond encryption, the unseen dangers of quantum computing. As tech giants like Google push the boundaries of quantum research, new and unsettling risks are emerging. Some scientists believe quantum computers might be doing more than just breaking codes or simulating molecules. They could be revealing hidden layers of reality itself. At the fringes of the tech community, there are whispers of experiments that have yielded disturbing anomalies. hints that quantum computers might be tapping into dimensions beyond human comprehension. These whispers grew louder when ethical hackers began uncovering anomalies in quantum research experiments. Some believe that certain projects may have accessed forces or phenomena far beyond their intended scope. The dark side of quantum computing. Quantum computing is often celebrated as the ultimate tool for solving humanity's toughest challenges. But like any powerful technology, it has a shadow side. Governments and corporations are racing to unlock its full potential. But one question looms over their efforts. What happens when we push too far? At its core, quantum computing is about breaking barriers, exploring the unknown, and bending the laws of physics. But when you bend the rules too much, unintended consequences tend to follow. And in the case of quantum technology, those consequences might be more dangerous than we ever imagined. One of the most concerning aspects of this technology is its ability to unleash chaos in ways we can't yet predict. Scientists are already using quantum computers to simulate complex systems, such as the human brain, chemical reactions, even the fabric of the universe itself. While these simulations hold immense promise, they also carry incredible risks. What if, in trying to replicate a system, we accidentally alter it? What if our pursuit of understanding disrupts the very fabric of reality? The ethical dilemma: quantum computing as a weapon. Quantum computing isn't just a technological tool. It could be a weapon. Imagine a world where authoritarian governments use quantum machines to monitor citizens in real time, breaking encryption to access private data instantly. Corporations deploy quantum algorithms to manipulate financial markets, controlling global economies with the press of a button. This isn't science fiction anymore. It's an imminent reality. The most unsettling rumors in quantum research. At the outer edges of quantum research, the whispers grow darker. Some believe that quantum computers might not just be processing data, but could be interacting with something deeper, something beyond our current understanding. A growing number of researchers suspect that quantum machines, through their ability to operate in superposition, might be connecting with alternate dimensions or parallel realities. While this idea is highly controversial, it isn't entirely baseless. The many worlds interpretation of quantum physics suggests that every quantum decision creates a branching reality. If quantum computers are leveraging these parallel worlds, what might they uncover? Or worse, what might they disturb? The ethical hackers sound the alarm. Ryan Montgomery and other ethical hackers have been raising red flags about some of the more secretive quantum research projects. Montgomery, known for pushing the limits of new technologies, has hinted at discoveries that go far beyond traditional cybersecurity concerns. His investigations into major tech firms like Google suggest that some quantum experiments may have produced results so bizarre or so dangerous that they were quietly shut down. According to whispers in the tech world, some of these projects were abruptly halted after generating unexplainable findings. Even more unsettling, there are claims that some researchers involved have been sworn to secrecy, forbidden from discussing what they saw or experienced. The final question: have we crossed a line we can't undo? What exactly were these quantum experiments trying to achieve? And more importantly, what did they find? This is where the ethical concerns turn into existential fears. In our relentless pursuit of quantum innovation, have we opened doors that were never meant to be unlocked? As we explore in the next chapter, the true consequences of quantum discoveries might be far more terrifying than anyone ever imagined. Quantum computing, a solution or a catastrophe in the making. Instead of solving humanity's greatest challenges, quantum technology might be unleashing dangers we're not prepared to face. In the next chapter, we'll uncover the shocking role Ryan Montgomery played in exposing one of the most controversial quantum experiments ever conducted, one that may have forced Google to shut down a project that appeared to glimpse into parallel universes. The truth may terrify you. Ethical hackers in the quantum era. In the high-stakes world of quantum computing, few are willing to ask the tough questions. Scientists focus on progress. Corporations focus on profit. Governments focus on power. But who is watching the risks? That's where ethical hackers like Ryan Montgomery step in. Montgomery has built a reputation for doing what others won't, pushing technology to its limits to expose vulnerabilities before they can be exploited. To him, ethical hacking isn't about breaking systems. It's about preventing them from being broken in the wrong hands. And when it comes to quantum computing, the stakes have never been higher. A new kind of threat. Montgomery's career began in traditional cybersecurity, where he specialized in uncovering flaws in networks, encryption, and firewalls. But as quantum technology emerged, he realized it posed an entirely new kind of threat, one unlike anything the world had faced before. Quantum computers weren't just faster. They were fundamentally different. The same power that could revolutionize medicine, artificial intelligence, and material science could also shatter digital security as we know it. Determined to understand both the potential and the risks, Montgomery turned his attention to the tech giants racing toward quantum supremacy: Google, IBM, and Microsoft. Not as an insider, but as an outsider looking in. Google's quantum secrets. What were they hiding? One of Montgomery's most eye-opening investigations led him deep into Google's quantum computing division, the team behind the Sycamore processor, which had made headlines for achieving quantum supremacy. Publicly, Google boasted about using Sycamore to solve complex mathematical problems and advance scientific discovery. But privately, Montgomery suspected they were venturing into much riskier territory. Using his hacking skills, he accessed classified files and internal logs related to Google's latest quantum experiments. What he found was unlike anything he had ever seen before. These experiments weren't just about computing power. They were probing something deeper. The files contained references to quantum tunneling anomalies, dimensional interference, unintended consequences, and then there was a chilling note: experiment terminated. Unforeseen results observed. For weeks, Montgomery sifted through the data, piecing together a narrative both fascinating and terrifying. It appeared that Google's researchers had attempted to test whether quantum computers could interact with parallel realities. The theory itself wasn't new. Physicists had long speculated that quantum superposition might connect to the many worlds interpretation of quantum mechanics. But what shocked Montgomery was the claim that their experiment had produced measurable results they couldn't explain. The disturbing signs of a breakthrough. During the experiment, researchers noticed something deeply unsettling. Qubits began fluctuating in ways that defied expected quantum behavior. Some researchers reported seeing strange distortions, light shifting, objects appearing slightly out of phase. A file referenced an information leak, suggesting data from another quantum state had somehow bled into their system. And then, without warning, the entire experiment was abruptly shut down. The logs revealed internal debates among the researchers. Some pushed for further exploration. Others warned that the risks were unknown and possibly uncontrollable. One particularly ominous note read, "Do not proceed. Risk to system integrity. Unquantifiable." The question no one wants to ask. Montgomery knew this wasn't just about corporate secrecy. It was about the implications. If the experiment had truly interacted with parallel realities, then what else might quantum computers be capable of? This discovery changed everything for Montgomery. He was no longer just hacking into systems. He was uncovering truths that could shake the very foundations of science and ethics. And as we'll explore in the next chapter, this was only the beginning, because the findings from this experiment would lead to one of the most terrifying revelations in the history of technology. The question now isn't whether we can push the limits of quantum computing. It's whether we should. Google pulled the plug on a quantum experiment, but why? The deeper Montgomery dug into Google's quantum research, the clearer it became. This wasn't just another experiment. The files hinted at something far more alarming. A discovery so unsettling that even Google, a company famous for pushing technological boundaries, decided to shut it down completely. But what exactly did they find? The experiment was originally designed to test the theoretical interaction of quantum systems with what physicists call alternative quantum states. In simpler terms, they were probing the possibility of parallel universes. A breakthrough or a catastrophe. Scientists had speculated for decades that quantum mechanics might hold the key to multiple realities. But what made this experiment different was its bold ambition. Not just to observe parallel realities, but to interact with them. At first, everything seemed to be going according to plan. The quantum chip performed flawlessly, running calculations beyond the reach of classical computers. But then, the anomalies began. Qubits started behaving erratically. Instead of simply performing quantum calculations, they appeared to be responding to something external. Have we gone too far? Did Google's quantum experiment inadvertently tap into something beyond our understanding? Did they witness evidence of another reality, one that we were never meant to see? Or worse, did they open a door that was never meant to be unlocked? Whatever the truth is, one thing is certain. The experiment was shut down and its findings buried. But for Montgomery, this was only the beginning of the mystery. Because if a quantum computer can reach into another reality, what else might it find? And more importantly, what might find us? A signal from the unknown. The anomalies weren't just unexpected. They were unexplainable. The data didn't simply provide results. It hinted at something more. Patterns, signals. Almost as if something or someone was reaching back. One log entry described a signal loop, the quantum system receiving information it had never processed. Another referred to unmapped interference, suggesting the presence of forces beyond their controlled environment. But the most cryptic file contained just one chilling statement. Observed data cannot be localized to our quantum state. The final straw. Then came the breaking point. According to the logs, researchers began experiencing disturbances they couldn't ignore. Lights flickered unpredictably. Subtle shifts in the lab's environment. Equipment malfunctioned without explanation. One researcher even reported feeling an overwhelming sense of being watched, as if the experiment had opened a door to something that couldn't be closed. Within days, the project was abruptly shut down. The logs made it clear. Google wasn't willing to risk the unknown. The experiment was terminated. The hardware was decommissioned. The findings were classified. But why? What had they uncovered that was too dangerous to pursue? Ryan Montgomery's discovery sends shockwaves. When ethical hacker Ryan Montgomery uncovered these classified files, it sent shockwaves through the tech and scientific communities. If Google's quantum experiment had indeed accessed parallel universes, the implications were staggering. But the bigger question was, what else could quantum computing reveal? And more importantly, what had Google decided the world wasn't ready to know? This is where the story takes its most terrifying turn, not just because of what was discovered, but because of why it was hidden. As Ryan himself put it, some doors should never be opened. But with quantum computing, we may have already stepped through the terrifying truth. Did Google find parallel universes? Ryan Montgomery recently stated, Google shut down its quantum chip after finding parallel universes. Here's the proof. Let's break it down. Montgomery's revelation about Google's terminated quantum experiment wasn't just another tech headline. It was a warning. This wasn't just a groundbreaking breakthrough. It was a Pandora's box. And once it was opened, it could never truly be shut. Speculation and fear. What really happened? After Montgomery exposed the classified logs, the scientific community erupted with speculation. Were the anomalies real? Had Google's quantum chip actually tapped into parallel universes? Or were these just glitches, misunderstood, even by the world's brightest minds? The lack of concrete answers was what made it all so terrifying. But one thing was clear. Google's researchers were so unnerved by their findings, they decided to shut everything down. The chilling debate, discovery versus disaster. Montgomery's files revealed heated internal debates within Google's quantum research team. Some researchers argued the anomalies were proof of a groundbreaking discovery, evidence that quantum computers could interact with other dimensions. Others saw the risks as too great, warning that further experiments could destabilize not just the quantum system, but potentially our reality itself. But the most disturbing revelation came from a final, buried note in the logs. Experiment classified under Section 5. Results not for public dissemination. Potential for existential risk acknowledged. This wasn't just a failed experiment. It was a controlled retreat. A decision to lock away something humanity wasn't ready to face. The race for quantum power continues. Montgomery didn't stop at revealing the files. He began speaking out about the ethical dilemma surrounding quantum computing. If Google had already stumbled upon evidence of parallel universes, or worse, unintentionally opened a bridge to them, what's stopping other companies or governments from doing the same? Quantum supremacy was no longer just a scientific race. It was a game of Russian roulette. And yet, Google's shutdown wasn't the end of the story. Whispers of similar experiments began surfacing. Other tech giants were rumored to be quietly continuing the work Google had abandoned. Some claimed governments had already seized the findings, working in secrecy to weaponize the technology. A haunting question. Have we gone too far? Ryan Montgomery left the world with a haunting question. What happens when curiosity outpaces caution? Quantum computing has the potential to reshape everything we know. But what if it's already gone too far? Perhaps the most terrifying truth isn't that we've discovered parallel universes, but that we might not be able to turn back. The doors have been opened, and what's on the other side may already be watching us. If quantum computers can unlock the secrets of parallel universes, are we prepared for what or who we might find